Hi guys, and welcome to my channel. Today we are going to be talking about special angles, and I will teach you where and how to actually remember the special angles triangle in a test. So let's start with this triangle, which I call it the 30, 60, 90 triangle. Okay. Now, this triangle, you have to know what type of a triangle it is. And this triangle is an equilateral triangle. And what does it mean if it is an equilateral triangle? It means that the angles are equal to each other as well as the sides, right? So in this case, what are the angles equal to? If they're equal to each other, they are equal to 60 degrees. You would remember this from properties. And also we're looking at sides, that the sides are equal to each other. In this case, we're just going to use 2 units for each side, right? So, okay, first thing that you need to remember is that it's an equilateral triangle, angle 60, and the sides we are going to use 2 units. And the second thing you have to remember is that from this equilateral triangle, we are going to try and make a 30, 60, 90 triangle, right? You would know the end product. This is the end product. The end product is that you guys know from your textbooks that you have a triangle like this, a 90 degrees triangle. They tell you this is a 90 degrees triangle. And then from there, they would then say, okay, that means this is 2 and this is 1. That would be 30 degrees, 60, and the square root of 3. But how do we know all of this, right? It's through this equilateral triangle, and I'm going to show you how we do this. Okay, from here, let's start here. Okay, so we have spoken about a lot of things at the moment. And the first one being that we have sides, angles, 60 degrees, and then I'm going to leave this here. Why? Because there's an adjustment that I have to make. Remember, I'm making a 30, 60, 90 triangle. So I am going to bisect this equilateral triangle into half, right? If I bisect this into half, I will be bisecting it. It will form a 90 degrees. And then what will happen now is that the angles will be 30 degrees and this will be 30 degrees, right? The full angle is 60 degrees, but because I've bisected it, this will be 30 and that will be 30, right? Now let's come to the sides. Now, if we look at the sides would then be, this would be 2, this would be 2 units, and this would also be 2 units. Please note that the entire thing, the entire side of this triangle is, of course, 2. Okay, so the entire side is 2, right? But because I've bisected it now, this will then be 1, and this would then be 1, right? Now, how do I get, what's the side that's missing now? Before I can actually come and answer these questions, I'm missing the square root of 3. How did they get the square root of 3? Guys, it is simple. It's something that you already know, and it's theorem of Pythagoras. Okay, so let's decide. This is the hypotenuse, and that is 2. So we are going to say 2 squared is equal to the other sides. I'm just going to use this one because remember, theorem of Pythagoras only works for right angle triangle. So at this point in time, I have 1 as one of the sides squared, and then we have plus, we have x squared, and then we have a reason, and we're going to say this reason is, of course, Pythag. Right, so we'll have 4 here, and we'll have 1 plus the x squared, right? And if we send 1 that side, we are going to get 3 equal to x squared. And you know, if I square root on both sides, so I square root on both sides, I'm going to get plus or minus the square root of 3. But now, because we're dealing with length, we are not going to write negative. So yes, it's plus or minus, but in this case, we're only just going to take the positive square root of 3. And the reason for that, as I said, it's because we are dealing with length. Right, and then we have completed our triangle, which you see there. If you see, we have 2 is the hypotenuse, we have 1, and that is opposite 30, and then the square root of 3, which is opposite 60. Right, so that's our triangle there. Now, here they're asking us something that we have to remember in a test. How do they ask special angles? They'll say determine the following without the use of a calculator. So, first thing we have to do, sine 60. Sine 60 is equal to, here's our triangle. I'm looking at sine 60. Sine 60, here it is. If you're looking at this acronym here, that sine is opposite over hypotenuse, right? So if it's opposite over hypotenuse, let's see. If I'm standing at 60, why am I standing at 60? Because 60 is the reference angle. Then we'll have the opposite side will, of course, be this one. And this is the square root of 3. Okay, so square root of 3 over the hypotenuse side. Guys, this is obvious. Hypotenuse side is 2, and that's our answer. Let's move on to tan 30. Tan 30, okay, it means I am standing at 30. Let me just erase some of the things that we don't need here. Okay, so we are looking at tan 30. Tan 30, we are standing at angle 30 in this triangle, and what is opposite me? Opposite me is, of course, 1, and then this side would then be the adjacent side. Guys, it cannot be, the hypotenuse cannot be the adjacent side. This isn't given that this is the hypotenuse, so therefore the adjacent side. So opposite over adjacent, here's tan here in this acronym, opposite over adjacent. So we are looking at, we're looking at 1 over the square root of 3. Guys, how do we catch you out here? You will see when you use your calculator, it will give you square root of 3 over 3. And another thing, you will not have this triangle if you're using your calculator because you're trying to cheat your way into writing your answer. Please note, you have to know this triangle so that you know how to answer questions without the use of a calculator. Now, let's look at number 3. Number 3 is cos 60. Right, let's erase everything here. The adjacent, okay, and where we are standing. We are now standing at 60. Okay, so we are standing at 60 because the reference angle is 60. And what is the opposite side here? Do we need the opposite side? No. The acronym of cos is adjacent over hypotenuse. So the adjacent side is what? So here, in this case, the adjacent side is this one because that one is also the hypotenuse, right? So adjacent will be 1. So now remember they've given us this 2. Let me just write it in blue so that you can see it. You have 2 times, and then cos 60. Cos 60 is 1. Right, so let's just write that fraction. We are looking at adjacent being 1 over hypotenuse, which is 2. And of course, 2 times half will give us 1. And that's your answer for this triangle. Right, so let's look at the second triangle. And the second triangle, this is the easiest one. You know why? Because it's an isosceles triangle. There's not much information here. Okay, so I'm looking at this triangle, and this triangle is number 1. Let's first do what we did on the previous triangle. What type of a triangle is this? This triangle is an isosceles triangle. Okay, and this triangle is called a 45, 45, 90 triangle, okay? Because we have 45 here, 45 here, and we have 90. So this side is equal to that side, right? And then now we're looking at what I like about this triangle is quite straightforward. Okay, the sides. You have 1, and you have the square root of 2. How did we get that? Pythagoras. 1 squared plus 1 squared is equal something that we don't know, which is the hypotenuse. I'll just call it x squared. So this will then be 1 plus 1, which is 2, we still have x squared on the right-hand side. And if we square root on both sides, guys, it will be plus or minus square root on both sides. So therefore, x will be the square root of 2. And remember, we're only going to write the positive because we are dealing with length. Okay, now this is quite easy. If they ask you to determine, for example, determine, okay, let me just write it properly. Determine, for example, number 1, tan 45. That means you are standing at the 45 angle. So what is, that's TOA, which is opposite over adjacent. So if I'm standing here, what's opposite me? It's that, and what's adjacent is that, right? Because this one is, of course, the hypotenuse. Never change it. So you have 1 over 1. So tan 45 will be equal to 1 over 1, which is equal to just 1. Even number 2, you can go sine 45. It depends on where you stand. It's up to you. If you're looking at, so you have the hypotenuse. For sine, you're standing at 45 because that's the reference angle, and you're looking at the opposite side, which is 1, right? And then the hypotenuse, which is, because is so, which is SOH. And that will be opposite, which is 1 over the hypotenuse. And the hypotenuse, we did say, is the square root of 2, right? So the square root of 2. How do we catch you out here? The calculator will give you square root of 2 over 2, right? Still the same as that, but we will catch you out. Why? Because you will not have your triangle next to your answer, and then your teacher will know that you just took the answer from your calculator. Okay, and that's it, guys. Thanks for watching.